Alright, now I'm going to work number 19 on the study guide. Now, again, I'm going to work it in a clever way. You can do it the long way. But see how it's a bunch of stuff? It's a polynomial. I've got like 3 parts. So I'm going to apply that sum rule, and you kind of apply the difference rule. They're really the same rule. But I'm going to break this thing up into pieces, find the limits one piece at a time, because these rules say that if you find the limit of the sum, it's the same as just the limits of the separate pieces added together. Same thing with the difference. So you're allowed to separate them. And I'm still going to kind of use that constant multiple rule that I used in the previous one. So you can use the constant multiple rule for at least for the first one and the second one, I guess you could say. And we want to find the derivative when x equals 3. So the idea is we use that definition of a limit. At the very end, we're going to be plugging in that x equals 3. So don't plug in the x value to the end. Don't do it at the beginning. You want to do it at the end there. So I'm going to grab this function, okay, and down here, okay, here's what I'm going to do. I'm going to separate this into 3 parts using my sum and difference rules. So I'm using the limit of this function here, excuse me, x plus h minus f of x all over, h. That's the definition of the slope of a curve that we learned in class, okay? So I'm going to separate this into 3 parts. I'm going to do the limit as h approaches 0 of this function, so at x squared, so this thing, which is, my parts are 2 times x plus h squared minus 2 times x. Now you can do it this way, but I like to do it, instead of even doing it like this, I'm going to factor out that 2 right away. So you have both parts of the numerator have a 2. I'm just going to do 2 times the limit as h approaches 0 of x plus h squared minus x all over h. And it goes much quicker. So the 2 is just hanging out. We expand this thing. You get x squared plus 2xh plus h squared. That is just this part. Just this part is this junk right here. We squared a binomial. Now I'm going to, I got the x. Whoops, I left off my squared there. Okay. So I'm going to do minus x squared, and then all of this is all over h. Again, the x squareds here are going to cancel out. Let me bring my little limit thing, because I still haven't substituted, so I haven't taken the limit just yet. Alright, and then we can factor out an h. There's an h, and an h. So it's 2 times the limit as h approaches 0 of, I'm going to factor the h out of the numerator. You get 2x plus h over h. These cancel out. Now we can substitute in 0. So it's 2 times, I can plug in 0 into this, 2x plus 0. Alright, and so, that's just 2 times 2x, which is 4x. So for the first part, what's x going to be? Well, later on we're going to plug in the 3. So I can plug in for the first part, because I'm only doing the first part. The limit is 4 times 3, which is 12. So part of my slope is going to be 12. Okay, now for the second part. Again, if you're wondering, I'm using these rules right here. When you have some functions added together, you can just take the limits of the pieces and then add them together. So now I'm going to do the limit as h approaches 0. I'm going to apply this rule again, but instead for the function 3x. Well, I could do 3 times, instead of putting x, put x plus h minus 3x, and then that's all over h. But I'm going to choose to factor out the constant. Again, this is just something I'm choosing to use. I'm making it a little easier. Again, you don't have to do this. But now I'm just going to do, okay, I get x plus h, because now it's just 3 times the function x. Okay? And then that makes it a little easier. Well, if you notice, you just do x minus x, you get 0. So we get 3 times the limit as h approaches 0 of h over h. Well, h over h cancels out to just 1. So what's the limit as h approaches 0 of 1? Well, that's just 1. So you get 3 times 1, so you get 3. So if you chose to do it that way, great. here's another thing. I'm not even going to use calculus here. 3x. What's the slope of that? Well, this part is just a linear function. The slope of 3x is 3. So it kind of makes sense that you would get 3 there. So far our limit is 12 plus 3. Okay, if you notice that there wasn't anything, you couldn't plug in the 3 into this one because it didn't give you an x. Now let's look at the third part. We're going to have that same issue where you're not going to get anything to plug it into. Now let's look at the third part. Okay, this third part, just think of the function y equals 8. What's the slope of that? You can try doing the limit stuff, but think about that. If you took the function y equals 8, 1, 2, 3, 4, 5, 6, 7, 8, is that just a horizontal line? What's the slope of a horizontal line? Well, the slope of a horizontal line is 0. So we got 3 pieces. We got 12 down here, plus 3 plus 0. So our slope is 12 plus 3 plus 0. So our slope is going to be 15. That's number 19, which really is going to lead into number 20. So next we're going to work number 20.